Hello everyone, welcome back to the channel. Here we are preparing you to crack placements in top companies. Today's video is about knowing the basics behind training a model and yes, creating an artificial brain in 10 minutes that can identify the difference between apparels. So let's start by thinking about the last time you saw handwritten number 5 or an ankle boot. Your brain instantly knows what they are. You don't consciously calculate the curve of the heel or the length of the laces. You just know it. But a computer doesn't have a visual cortex. It doesn't perceive loops or shapes. When we feed this sneaker into a machine, all it sees is a grid, a 28 cross 28 grid of pixels where every single square is just a number from 0 to 255. For decades, programming a machine to understand that these clusters of numbers meant true was nearly impossible. Today, we are going to look under the hood of the math machine that finally solved the puzzle. To teach a machine, we use digital flashcard. We take that pixel grid and unroll it into a single vertical line of 784 individual data points. We then show the network 60 thousands of these examples. Here is the secret. We don't give it answers to everything. We hold back a quiz, the validation data. A brand new network is entirely naive. It starts with random values and makes chaotic, often hilarious guesses. We use the quiz to make sure it isn't just memorizing trivia, but actually learning the patterns. And the machine starts to work exactly as the human brain, having neurons. But these networks don't think like us. They are highly organized math machines. The core of the whole system is actually middle school algebra. Y is equals to W dot X plus B, where X is the incoming pixel values and W is the weight. But this is crucial. It's a knob that determines how important a pixel is. If a dark pixel in the corner is vital for identifying a number 5, the connection gets a heavier weight. And the B is bias. Think of this as a threshold. It dictates exactly how high the pixel scores need to be before the neuron decides to fire or activate. Now, linear logic is rigid. To handle the fluid complexity of a shoe or a digit, we need to bend these straight lines into curves. We use functions like sigmoid or ReLU to create squiggles. By stacking these bent lines, we create a hierarchy. Layer 1 might only detect simple edges. Layer 2 combines those edges into loops. Layer 3 finally recognizes concepts like a sole or a lace. It is thousands of tiny, bent mathematical operations working together to transform raw pixels into a decision. So, how does it learn? We use a grader called a loss function. If the network confidently guesses shirt for a bag, the grader issues a massive error penalty for being confidently wrong. The network then goes through epochs, repetitive training sessions where it reviews the data over and over. After each epoch or after each pass, an optimizer like Adam makes microscopic adjustments to the internal knobs, the weight, and the biases to ensure that the penalty is slightly lower than the next time. In code, we represent this by flattening the grid and defining a dense layer with 10 output neurons, one for each category. Each neuron spits out a logit or a confidence score. The network simply looks across the layer and picks the highest number. I am confident it is this one. AI doesn't dream. It doesn't possess consciousness. It is an elegant, automated, squiggle fitting math machine that solves a decade old paradox through sheer computational scale. It isn't magic, it's just math. Thank you for watching Placement Ready. Do subscribe and share if you like the content. Thank you so much.